they ask which estimate is reasonable. Let's go one by one. 1 times 10 to the power of minus 3 kilogram means it's minus 3 times 1000 grams. So it is 1 gram. 1 gram is much bigger than mass of a grain. So answer A is not good. Let's think about answer B. 1 times 10 to the power of minus 2 cubic meter for the volume of a tennis ball. Let's just imagine how much is the volume of a tennis ball. Maybe 200 cubic centimeter, like 200 milliliter water. You can fill it into a tennis ball. So if you convert it into cubic meter, it ends up this much. But if you look at this number and the given answer is much bigger than a reasonable estimation. So this is also not good. Let's think about, now I jump into answer D. We are talking about a light bulb. Look around in your house. Power ratings of lamps. LED lamp could be 5 watt or 20 watt. Filament lamps could be 100 watt or even 60 watt or even 100 watt. So 1 times 10 to the power of 10 to the power of 4 is 10,000 watt. That's too big. So this could be an air conditioning system, but definitely too big for a light bulb. So you remove it. Now answer C is slightly confusing because of this 10 to the power of 0. We need to understand 10 to the power of 0 of any number is 1. So we are talking about 1 joule. So just think about mass of an apple. Let's say mass is 0.1 kilogram. Height from your hip to head 1 gram. G is 10. 1. So you get 1 joule. So this answer is the right answer. Question number 2. Question number 2 is tricky because we know temperature SI unit is Kelvin, but here in answer D, Kelvin has that like Celsius. This 0 should not be there. So answer D is wrong. It's very much possible you made a mistake by choosing answer D, but correct answer is answer B. So I will remove this. Now question number 3. Which statement about systematic errors is not correct? Systematic errors. A systematic error, answer A, can be caused by using incorrectly calibrated instruments. True. Let's think about an ammeter. Let's think we have calibrated milliamperes into ampere. So all the readings are actually 1000 times bigger. So 5 milliampere, you mark it as 5 ampere. So what happens, the current calibration graph, this is the expected graph, but all the numbers have increased by 1000. So it can end up like this. So answer 1 is right. So they are not correct. So answer 1 is right. So we don't accept it. Second one, one particular type of systematic error can affect all the measurements by same amount. Like let's say 0 error. Let's say you have your meter ruler does not start from 0. It's 0.2 centimeter is the starting point. So all the readings are affected by same amount, means this should go down. Real value is 5.0. This is 10.6. This is 12.3. This is 15.2. So everyone is affected by 0.2 centimeters. So like 0 error. So this is also correct. And so let's jump to D. 0 error is a type of systematic error. Yes, 0 error means that the instrument does not start from 0. That issue is a systematic error. Let's think about C. The effect of a systematic error can be reduced by repeating an average in the measurement. No, this is what we do for random errors. Random errors can be reduced by taking average. Let's think about this one. Let's think all your readings have a systematic error of value A. So when I take average, but this A actually becomes 3A divided by 3. In this example, it is still there. So taking average is not a solution for systematic error. Taking average can reduce random errors. That's why this answer is wrong, because repeating does not help with systematic errors. Question number 4. Now in this question they ask what is the change in velocity. So let's start with defining change of velocity. Change of velocity is final velocity minus initial velocity. Final velocity is this way. If you look at the picture, final velocity is like, let's say, southwards, and initial velocity is eastward. So by changing the direction of this vector, I can make this one positive. So it means actually they are asking what is the addition of these two vectors. It is in this direction, which is northwest direction. So let's find which answer has northwest type of direction. That is answer B. So answer for question number 4 is B. Question number 5. A car travels anti-clockwise along a horizontal circular road of radius 12 centimeter. It takes 4 seconds to move from P to Q. They ask average velocity. Velocity is change of displacement over time. Now displacement is not this whole length of the path. This is not displacement. Displacement is from P to Q straight length. Now we know from trigonometry, if this is R, the angle between them is theta. This length from A to B is 2R cosine theta over 2, half theta. We can use this logic here also. So I am trying to find the length of this, let's say, blue line. So according to that logic, 2R cos half theta means 2R cos half theta means 45. And the time for this motion is 4 seconds. So you get 4.2. Answer is A. Question number 6. The water surface in a deep well is 78 meters below the top of the well. Person at the top of the well drops a heavy stone down the well. Air resistance is, that's very important, negligible. You don't have to consider air resistance. The speed of sound is this much. What is the time interval between the person dropping the stone and hitting it, hearing it hitting the water? Okay, let's go. Let's find the first. Using this equation, we can find the time for stone to fall 78 meters. S equals ut plus half a t squared. Starting speed is 0 because he drops. So you can, time is 2h over g square root. You can find this number. And then now sound has to come to the person from the bottom of the well to the top of the well. So distance divided by speed is time. You find that time. Now the total time is the addition of these two. Use your calculator. You will get 4.22. So answer for question number 6 is D. Question number 7. Which statement is not a requirement for a pair of forces that obey Newton's third law of motion? Action-reaction pairs. Very good situation I thought about is, think about a person who is falling under gravity. Like, let's say he jumped out of a plane. So he is falling towards the earth. So he has weight or gravitational force acting on him. And what we don't realize is there's the same force of mg or weight on the earth. Now you can ask, okay, if there is mg force, why earth is not moving? Because earth is so heavy and big and it has such a high inertia, it will not move with this force. But man is falling because of that force. Now the question is this man and the earth, are they in contact? Of course not. Man is still further from the earth. So they don't have to be in contact. What I am trying to say is, answer C, the forces act on objects in contact. No need. They don't have to be in contact. So what are the conditions for action-reaction forces? Same size, acts on two different and opposite direction, and same size, and act on different objects. These are the three conditions. 1, 2, 3. Answer C, acting on objects in contact is not a requirement. Let's focus on question number 8. This is a really good question. What we have to understand first is when the child is, there are two key points in this question. When the child is pulling this rope, of course child feels the force forward tension, which is 12 Newton, and that tension is same everywhere because this is the same string, so it acts on the sledge also 12 Newton tension, and it acts on this pole tension 12 Newton, again tension 12 Newton, but this side we actually don't care. Why? We don't want to know what happens to this pole. We want to know what happens to this child and the sledge. Now I tried to take one by one. Let's think about the child. Just think, if this child is, how does he pull this one? Obviously he presses his legs and pushes his legs forward, so friction on this child is backward. That's second point we have to understand. So for the child, tension is forward, friction is backwards, so we can, and we know the value of tension, but to find the friction we need acceleration. So let's think about the total system. System has mass 60 kilogram, boy has 20 kilogram, sledge has 40 kilogram, altogether it is 60 kilogram, right? Now the friction is an internal force. See, the child experiences friction backward, the sledge experiences forward. We don't have to care about this because this cancels out. So the two tensions act on, one on the child, one on the sledge. These are the two forces, and so we can write F equals ma. Acceleration is force divided by mass. Total mass is 60, total tension is 24, acceleration is 0.4. Now you can use this one for the boy. For boy, I write F equals ma. Forward force is tension, backward force is friction, is m is mass of the child, 20 times acceleration. F, I find F equals T minus, I can write T minus ma. T is 12, m 20, a 0.4. You get answer friction as 4 Newton. So question number 8, answer is A. Now let's focus on question number 9. Question number 9, let's think about a spherical object moving inside the liquid. Let's forget about, let's forget about fluid. Let's think it's falling under gravity. So the mg force is there, and friction force on a solid spherical object is 6 pi eta radius times speed. So at terminal speed these two forces will cancel out. So I write this equation. From there I can find your terminal speed depends on the mass of the object. Heavy objects move at a higher terminal speed, lighter objects move at a lower terminal speed. That's a very important understanding. Now is there any situation I can explain? Let's think there are two people for jumping out of a plane, parachute jumpers. Okay, one is let's say first one is pretty thin, like maybe 60 kilograms, and second one is like, I don't know, 90 kilogram. Obviously if you check their terminal speeds just before they are opening parachute, terminal speeds, this one moves with much higher terminal speed than this one's terminal speed. So terminal speed depends on the mass. That is an important understanding. Based on that, see, both of them are starting at same acceleration. Find who is heavy, rubber or stone, same volume. So stone has bigger mass, stone should have a higher terminal speed. This is wrong, they don't move at the same terminal speed. This is wrong, this is the opposite of what I am saying. So answer for question number 9 is B. Stone will move at a higher terminal speed. Question number 10. Completely elastic collisions, there's an equation, Newton's law of restitution. You can look at this picture. If an object is coming at speed u1, another one is going at u2, of course u1 is bigger than u2, that's why they are making a collision. After this is before the collision, this is after the collision. Now if they go at V1 and V2, these four variables for elastic collision, completely elastic collision, is given by this equation. Remember, u2 minus u1, v1 minus v2 is u2 minus u1. Now you have to use the same concept for this situation, but if everyone must be moving to the right. If anyone is moving to the left, we have to mark it as with the minus sign. So let's check this. This is good. I am talking about the direction. Let's think this one is going to the right. This one is going to the right. So, but this one u2 should be marked as minus. So when you add the numbers into equation, you should write u2 as a minus number. Let's see. v1, good, v minus 7. Hold on, v1 minus v2, u2 minus u1. u2, see what I did? Minus sign, minus 15 minus 5. From there I get speed or velocity is minus 15. It means it's not going to the right, it's going to the left. So question number 10, answer should be the first ball will be moving to the left with 13 meters. How did ours? Let me check. Oh, sorry, I made a mistake. This is 20, so 13. So this should be to the left 13 meters per second. Answer is B. Question number 11 is about a couple. Couples. In physics, a couple means two parallel forces. They must be in opposite direction. They must be of same size, and they should not act on the same line. They should have a gap between them. Example, in this one, see, same size, opposite direction and parallel, but they are in opposite direction. So if you look at this one, they have the same magnitude is a condition. They are in the same direction, no, they should be in opposite direction. They are perpendicular, no, they should be parallel. They pass through the same point, no, they should have a gap between them. So only this condition is correct, others are not correct about a couple. Question number 12. A uniform rod is attached by a hinge. Okay, there's a uniform rod. Uniform means the center of gravity is at the center. So the weight of the object is like this. I will mark it as mg. And on this string there's a tension. Now let's think about, there are three forces. What are those three forces? One is tension, one is this weight of the rod, and there's a force on this hinge. Now three non-parallel forces. If there are three non-parallel forces, they must create a closed triangle. For that, in real life, what it means is this force, the third force, must pass through this intersection point. Otherwise, this can't be in equilibrium. Sorry, this like this. Let's say S. So this is a must. This idea is called concurrent forces. Otherwise, this can't be in equilibrium. See. So they ask, it is in equilibrium. So they ask what should be the third force. Obviously, it should be in kind of northeast direction, not exact northeast. What I mean is into that region. So answer has to be D. Question number 13. Now this is talking about a child of 40 kilogram stands at the edge, and of course this diving board has a weight, the spring has a force, there's a hinge force. We don't care any of these things. We are thinking about what extra things will happen when the boy stands at the edge. So at that time there will be, let's say at that time there's a hinge force here because of this boy, let's say S1, and there's a force on the spring F, and the mass weight of the boy is 40 times 9.81 Newton acts on the board. These are the three extra forces without considering the weight of the plank. Now I am going to take moment around this point, let's say point A. So by taking moment around point A, resultant moment should be 0. Force times distance is 5 meters. The force in the spring from the spring is upwards, times distance is 2. From there you can find the force on the force equals mg times 5 divided by 2. But this should be again F equals kx, right? So k is in kilonewton, I change into Newton, x is the extension, I get answer in meters, so I change into answer in centimeters. How? By multiplying 10 to the power of 2, this cancels, I get 9.8 centimeters extra extension. What it means is, let's say it has had extension at the beginning 15 centimeter. Now new extension will be 15 plus 9.8, 24.8 centimeter. This is what this means. Extra extension is 9.8. So this question answer is C. Question number 14. Now they are talking about a granite rock. Surface of earth is density is rock, and it is taken into another planet. The g dash is twice. That does not matter because density definition is mass or volume. Mass does not depend on the planet, so it doesn't matter. Volume does not depend on the planet or gravitational acceleration. So mass stays the same, volume stays the same, so the density. So answer is B. Question number 15. For this we need a very important background knowledge. The pressure at the same horizontal level of the same liquid is the same. This is the knowledge we need. So in this case I am writing pressure at A equals pressure at B. If you like, you can write here, but then this height will cancel out, so it doesn't matter whether you write for these 2 points or A and B. I write for A and B. First thing to understand is, if this is Y, if this is C, the height of this liquid is Y minus C. So pressure at A is, if you look at the question, this pressure is P1, this pressure is P2. So P1 equals, second one is pressure plus liquid pressure H rho G. This is the equation I am using, H rho G. From there P1 minus P2 is Y minus Z times rho G. This is the answer. Answer is C. Question number 16. Which product of two quantities is equal to power? Power definition is work done or energy over time. How much work you do in a 1 unit time or 1 second time. And work is force times distance divided by time. Distance over time is speed, or you can say velocity. So force times velocity is a derivation of the same equation. So power, if you look at any other thing, force times distance is work. That's not good. Work times work done times time. This one makes no sense. Work divided by time, we have a meaning, that's power. Work times time makes no sense. Work done times velocity makes no sense. So this is the answer. Question number 16. Sorry. Question number 17. Researchers have developed a new type of filament lamp with an efficiency of 40%. Good. All efficiency is 5%. They make the same useful output power. So we know if you give power in, power out will be power in times efficiency. So I am using the same thing. Old lamp, if you give power, whatever the power in you give, 5% of that will come out. New lamp, 40% of power in will come out. They say these two numbers output are the same. So I wrote that these two are the same. From there they ask power new type and old type. So we are focusing on this should be, hold on, the power, this should be on the top. So be careful in the calculation. P new over P old becomes 5 over 40 or 1 over 8 or 1 over 0.13. Answer has to be A. Question number 18. Now I am going to erase question number 17. Hold on. Question number 18. A student attempts to deliver the formula for kinetic energy, and they ask which equation would the student not need to in order to derive the kinetic energy equation. How do we get kinetic energy? Let's think there's an object which is starting from 0 speed, end up with speed v at s distance. So because of a force F, okay, a constant force. So work done is the kinetic energy. If someone is doing work on you, you will get energy. So kinetic energy is the work done on the object, force times distance. So we use this one. Second, but we know for this type of constant acceleration motion, we can use SWAT equations. Or one of them is v squared equals u squared plus 2as. From there, we can get an equation for s or displacement, and I can put it here. That's the second step. Now we are here. Third, for f, we can use f equals ma, and we can substitute ma here. So ma v squared over 2a, sorry I forgot a here, so this cancels. This is how we end up with mv squared over 2. So we have used work is force times distance, f equals ma, and this equation, have a look. So we have used f equals ma, w equals fs, and v squared over v squared equals u squared plus 2as. Only thing we have not used is this equation. This is for a spring or something. Anyway, this we never use for the derivation. So answer for question 18 is C. Question 19. Question 19, first thing to understand is cross-sectional area of a circle is a circle for us wire, and you can write it in two different ways, pi r squared, or pi r is diameter over 2, pi r squared over 4. So this is the equation. We know the area. Second, Young's constant is FL over AX. From there, I can make F as the subject. This is X as the, what I mean is you can change it into F equals something times X. So this must be the K. So spring constant is EAO. So spring constant is EA over L. Put that Young's constant value, cross-sectional area is divided by 4 times length. You will get the answer, which is 2.2 something, 10 to the power of 4. So spring constant is given in answer B. Question number 20. The confusion with most of the students is what is elastic, what is plastic. Elastic, they think it has something to do with graph being a straight line. No need. Very good example is, think about rubber. Rubber has very short proportional region like straight line. Mostly it is a curve. But being elastic has nothing to do with whether graph is a straight line or not. As long as you can come back, hold on, you can go and you can come back to the zero displacement, you are elastic. So we have to remove anything about being proportional concepts. The deformation is plastic after the, no, let's think about answer B. The deformation is plastic until the elastic limit is reached. No other way. The deformation is elastic until elastic limit is reached. The extension is proportional. No, it has nothing to do with being a straight line. Extension is proportional. No. The deformation is plastic after. Yes, after this point, it will be permanently damaged. It will come back like this. See, there's an extension. So, remember one thing. Being elastic or plastic is not about graph being a straight line. It is about whether when you release the force, it can go back to the same size. That's the idea about being elastic. Answer is A. I will erase this one. Question number okay, question number 21. Which statement is correct for all, that's the keyword, all types of progressive waves? Let's think about answer A. The distance from a peak to the next trough is a wavelength. What? Peak to peak is wavelength. Peak to trough is half a wavelength. So this is definitely wrong. They can be demonstrated in ripple tank. Yes, but only if it is water waves. Sound waves can't be demonstrated in a ripple tank, right? You remember, you need to fill water. So sound waves has nothing to do with, cannot be demonstrated by ripple tanks. They consist of vibrating atoms. Now you can ask, what about electromagnetic waves in a vacuum? In vacuum, there are no vibrating atoms. So, but still light or electromagnetic waves are progressive waves, right? So all these three are wrong. They transfer energy from one position to another. That's why progressive. Progressive means energy moving, or no, actually propagating. Energy is actually moving in the space. So any progressive wave has to carry energy forward. So answer is D. This looks scarily difficult, but actually it's a very simple question. They say frequency is 0.2 hertz and amplitude is 0.7, and distance traveled by, they ask about 20 seconds, and they ask about a particular ball, how far this will move, how much distance this will move in 20 seconds. All right, let's try. F equals T equals 1 over F. So from there you can find the oscillation period for this ball, that is 5 seconds. So that time is actually divided by the period. You can say it is a 4 period time. But in 1 period time, if you look at on the left hand side of the screen, you can see this is 7 centimeter, 7 centimeter, and then again back. So it is these times 4, 7 times 4 distance it travels in one oscillation. Now, 1 period time. So we have 4 of them in 1 period time, 4 of these, and we have 4 periods. So altogether 11.2 meters the ball will be moving within these 20 seconds. Answer is C, 23. A sound wave travels from left to right across the room. The variation, now wave goes from left to right. Best way to understand, they ask which place the lowest pressure be lowest, like a rarefaction. You know, sound waves are made of rarefactions and compressions and normal pressure places. These are the high pressure places, these are low pressure places. We are looking for a rarefaction. Think like this. Think we have 3 particles, and if you take right hand direction positive, it means here this particle has moved to the right. This one is negative, so it has moved to the left. So what happened is these 3 particles are like this. They were supposed to be like this, but they have moved closer. So this is a compression, right? And if you look at this place, here, another 3 particles. On the left hand side, it has gone to the left. See, negative direction. On the right hand side particle, it has gone to the right. What it means is they have gone like this, like this. What is this? Is a compression? No. Normal pressure? No. It's a rarefaction. So this is the lowest pressure point. So you should choose answer D. Question 24. A source emits a sound wave of a single frequency. Doppler effect causes a different frequency of sound to be heard by a stationary observer. Alright, what is Doppler effect? Doppler effect, let's try to understand here. This is the observer, and this is the, let's say, the sound source, and sound or any wave source, does not matter actually. So the Doppler effect is, if they are moving either towards or away from the source, or source moves towards or away from the observer, the relative motion creates the frequency. The frequency the observer hears, if it is a sound wave, is not the same frequency as the frequency released by the source. So a source that is moving, yes, motion is a must, otherwise there's no Doppler effect. A source that produces a polarized, what? Sound waves polarize? Sound waves can't be polarized. Simple like that. Source that produces sound wave of changing amplitude. This one, Doppler effect, is not about amplitude, it's about the frequency. So we remove that one also. A source that produces sound wave of changing frequency. No, the source never changes frequency. It's a constant frequency. Our perception, our understanding of that frequency, the way we hear, only can change. So this is also wrong. Answer is A. Question number 25. Electromagnetic wave in free space has a frequency this much. What region? Okay, it means wavelength. We can find wavelength. Lambda equals V over F. I put these numbers, I get 1.2 10 to the power of minus 6. Actually I can write is 1.2 10 to the power of 3, 10 to the power of minus 3, 10 to the power of minus 6. So 1200 10 to the power of minus 9 meters. This is nano, so 1200 nanometer. We know 400 to 700 nanometer is visible light, right? So below this one is ultraviolet. More than this one is infrared. So this must be infrared. That's why answer is C. If you go even further, it will be microwave, but this is like 1 centimeter range, but this is not centimeter range, this is micrometer range, so it has to be infrared. Question 26, two polarizing filters. Let me erase this one first. Two polarizing filters are placed next to each other, so this is a very good question. So let's read. The beam is vertically polarized. A beam of vertically polarized, already polarized light, 8 watt per square meter is incident normally on the first polarizing filter. Then they ask how much is the intensity coming out. This is the question. So first polarizer, let's think about it. The polarizing direction is vertical and polarizing filter is 50 degrees. So by Malu's law, we know I equals I naught cos squared phi. So angle is 50. I found the intensity emerging as 8 cos squared 50. I don't want to find the number. I am going to use this. Now tricky part is second one. Now there are two polarizing filters. I mean first one is there and the second one has 20 degree angle. So 20, first one has 50. So the angle between them is 30. This is the angle which is very important, not the real numbers. We want to find the angle between the two polarizers. So again I use I equals I naught cos squared phi, but this one is the filtered, I mean first polarizer sends this much intensity and it will be cos squared 30. If you do the calculation, 8 cos squared 50, cos squared 30, 2.47 or rounded up into 2.5 watt per square meter. So question number 26, answer is B. Now let's try question number 27. A stationary wave on a stretched string is set up between 2 points P and T. Okay. They ask what are the correct statement. Which statement is correct? We know these are called antinodes. This is an antinode. This is an antinode. And this any 2 points between these two, phase difference is 180. We know that. And any not the next one, the one after, phase difference is 0. They are in phase. Any 2 points in these loops. So let's check first one. Point R is at a node. No, it is an antinode. So second, let's say C. The distance between P and T is 3 wavelengths. P and T. No, this is 3 half wavelengths. A loop is a half wavelength only. So this is 1.5 wavelength actually. The wave transfers energy. No, stationary waves don't transfer. They store the energy. So points Q and S vibrate in phase, of course, because they are not the consecutive loops. They are the loops. There's a loop in between these two loops. So they are in phase for sure. Question 28. This is a very good question again. How much a wave diffracts depends on two factors. What are those? It depends on the size of the gap and it depends on the wavelength of the wave. Now think about this. Let's think this wave spreads out and the intensity and distance graph for this situation is like this. What it means is there's a bright fringe here and then darkness, again bright, here bright, like this. And listen to me for a minute. This angle shows how much it spreads, diffraction, amount of diffraction, and it depends on lambda and b. We can get this equation by this equation. So if theta is big, it means it spreads good diffraction. Now but the question say we don't want diffraction, we want the smallest angle of diffraction. We want to stop it. So idea is theta equals lambda over theta equals lambda over b. If you don't want it for theta to be small, lambda has to become small or b has to be bigger, because b is under the line. So but lambda is c over f, because they have given us frequency. So from this equation I put, instead of lambda, c over f. So if you want to make this one small, you have to make both of them bigger. That's why answer is D. Sorry, this equation is not in the syllabus, but it is useful to know this equation. Alright, next one. In an outdoor concert has two large speakers beside the stage. Okay, wave fronts. Loudest sound, loudest. So they are talking about constructive point. We know the sound or any other wave is made of crests and troughs. So what is missing here is troughs. Let's draw some troughs. Means like we say peaks and valleys, right? So I am drawing the lower places like by these broken lines. Now the thing is, if these type of places A, this means peak plus trough. No, not good. That's not construction. Here all let's say B also, see, this is a peak plus trough. No, not good. But what about C? The problem is C is neither trough, neither peak. Again, it is not a clear place. I mean, it is not the good place. But if you look at D, this is peak plus peak. That is very good. That's a constructive place. So answer has to be D. Answer is D for question 29. See, peak plus peak is good. Trough plus trough is good. That's our constructive places. Peak and trough is bad. So you get answer D. Now, for diffraction grating, we all know this equation, that's d sine theta equals n lambda. What d represents? If you look at diffraction grating very, very close using a microscope, you will see it is made of small slits, gaps, and the distance between them is called slit separation, and that is d. So this is called slit separation, or actually size of one slit, you can say. And this nth order, this is 0th order, first order, second order, in this example nth order. So this is n is called order number. So let's check. N is number of slits. No, it's not about slit. Order of intensity maximum. Yes, this is right. Now what is D? D is the distance between adjacent slits. That's right. Distance from grating to screen. No, it has nothing to do with this d sine theta equals n lambda equation. So this is not relevant. They ask to write an expression for current I in these symbols given. What do we know about current I? Current is in a better way dq over dt, or in a simple way q over t. But actually current can be changed into A, V, N, Q. A being the cross-sectional area, we know this equation, right? V is the drift velocity of the charged particles. N is the number density. It is a constant for that material. And Q is the charge of one charged particle. Alright, now let's try to use this one. The thing is, we have to understand it. Electrons or charged particles, no, actually this is current. So charged particles are actually moving this way, right? So cross-sectional area is this surface. How much is the cross-sectional area? Let's come here. A equals this is A, this is C, so A times C. Now what about the speed? Let's think about the speed. Speed is distance over time. The charged particles, let's say speed is it has to cover distance B, see, distance B, and the time taken is t. So from there we have an equation for speed also. And volume of this total volume is A times B times C, right? Let's remember these three things. Speed has an equation, volume has an equation, and cross-sectional area has an equation. Now let's use this one in this equation. Cross-sectional area is, okay, C times A. Speed is B over T, and number density is given. Charge of one charge particle is Q. I will use red mark, so we know all these four. Now CA times B, I can write ABC. ABC is the volume, right? We know, we found it here. And now remaining thing is N and Q over T. So this V is not that previous AVNE, that speed. This is volume V. So volume V N Q over T, or according to the marking scheme, the given answer is NVQ over T. This is the answer B. So question number 31, answer is B. Let's go to question number 32. There are two lamps. One is 9.6 ohm resistor, current is 0.5 ampere through that. This is 3 ampere going through 1.2 ohm lamp. They say, what is the ratio of power in X, power in lamp Y? Let's think about power. Power has three equations: VI, or I squared R, or V squared over R. All these three are for the power of an electric component, right? Now, easier way is to pick this one, because what we know is current and resistance. So I use this equation. So I will come here. For lamp X, I wrote the equation. For lamp Y, I wrote the equation. I divide Px over Py. See, power of the lamp X, power of the lamp Y. If you use the calculator, you can get 0.22. Answer is A. Clear? Let's go to question 33. Question 33 says there's an LDR and light intensity is increased. Okay, light intensity is increased. So what do we know about LDRs? We know when the resistance of when the light intensity increases, the resistance of an LDR decreases, but they tell us that we keep the current constant. So it means if the resistance decreases, when the intensity increases, resistance decreases, current does not change. So voltage across that one has to decrease, right, in a potential divider circuit. Now in another circuit, we have a thermistor. Thermistor symbol is like this. Sometimes we draw thermistors like this. It's the same thing. So thermistors also have resistance decreases when the temperature increases, right? So when the temperature increases, resistance decreases. If the current does not change, resistance decrease means, according to this equation, voltage has to decrease. So both ways voltage has to decrease, right? So answer is D. Let's go to question number 34. An iron wire has length this much, diameter this much, wire has resistance R. Another iron wire has length this much, diameter this much. What is the resistance of second wire? Okay, let's try to remember which physics is relevant to this one. We know resistance of a wire depends on three factors. What are they? Resistance of a wire depends on length, cross-sectional area, and resistivity. Good news is iron wire means both of the resistivity is the same. You don't have to worry about it. Problem is, what is the cross-sectional area of a wire? It's a circle. So this area is, you can write in two different ways: pi r squared or pi d squared over 4. D means diameter, which is twice of the radius, right? So I am going to use this one. Now when I put this one into this equation, rho L over A, it ends up like this. But I can see actually there's an easier way. Rho, 4 and pi, all three are constants, right? So in that case, hold on. So in that case, you don't have to worry about those things. You can just think about length and diameter. So that's what I am going to do. I am going to use resistance of second wire is his length, hold on, and his diameter square resistance of first wire. his length, his diameter squared. If you do the calculation right, I get 1 over 16. So resistance is 1 R over 16. The answer is A. Alright. Let's focus on question number 35. Cell with constant electromotive force is connected across a fixed resistor and internal resistance. The cell increases when the over time internal resistance increases. Which change occurs as the internal resistance of the cell increases? Let's have a look. We know an voltmeter is actually a very big resistor, right? But how much it can read, how much this voltmeter reading is close to EMF depends on how small this R is. So loss voltage is not a problem if this R is normally a small number. But when R increases, lost voltage also increases, because example, let me give you an example. Let's think this is 9.000 volt EMF. Okay. Now let's think this one takes 8.9 volt. This is only 0.1 volt. But then this resistance increases. This gets more important. So this resistance now starts getting 0.3 volt. Obviously this has to go 8.7 volt, right? Because total voltage still has to come to 9. That's why here we say the decrease in the potential difference measured across the cell. What I mean is the voltage output or terminal potential difference will decrease, because part of the voltage goes into internal resistance. Or if you are confused, we can think why this answer A is wrong. A decrease in the charge of each charge carrier. What? Charge carriers are electron. Charge of an electron is this. It can never change. So this is wrong. An increase in the energy dissipated per unit time in the fixed resistor. If the current decreases because resistance increases, current decreases, power through this resistor is power equals I squared R. This decreases, this has to decrease. So increase is impossible. Increase in the number of charge carriers leaving the... Now, just now I told you current is decreasing. So if current is decreasing, number of charge carriers, so less electrons are going through the wire in a unit time. So part D also wrong. Answer is definitely answer B. Question 36. Kirchhoff first law and second law. First law, what is first law? First law says in a junction, this is a junction in a circuit, the current coming in and current going out cancel out. Or let's say this is 2 ampere coming, 5 ampere coming, 3 ampere going, 3 ampere going. How much is this current? We know it is 1 ampere. Why? Because coming current has to balance going current. So this is based on current is charge per unit time. So it is conservation of charge. So answer has to be, answer has to actually, even just considering first law, you can get the answer. Answer is A. You don't have to look for any more answers, because second law is about conservation of energy. Energy is only here. The other one is not energy. 37. Now this is a very good question. Potentiometer. Let's check what's wrong with each potentiometer circuit. Let's think about potentiometer background. What we know is we need a big cell, like let's say example 20 volt cell, and we connect this through a resistance wire, and then we connect our cell, the one we want to measure the EMF of. We connect it here, and through a galvanometer we connect it somewhere here to find the balance point. Example, if this is 20 volt, maybe this is, I don't know, 12 volt. So the question is, few things to observe. What are they? One, this positive to negative, this also should have same pattern. Second, galvanometer should be here. 3, this 20 should be more than 12 volt cell. 3 things. Okay, doesn't matter, you can connect other way. What I mean is you can connect this way, but then other cell also should be this way. Three conditions. What are they? Galvanometer should be with the small cell, and this should be the smaller cell, and the order positive to negative pattern. Okay, let's go one by one. Look at this one, wrong order. Good, no need. Now look at B. B problem is this is the smaller cell. See, this should connect the bigger cell, so this is also wrong. Look at this one. This seems like good, but see the pattern order, I mean negative to positive, good, and this one is the bigger one, this one is the smaller one. Second condition is also satisfied, but the problem is this: the galvanometer should be on the flying lead, not here. So this is also wrong. Answer is D. Think about the three conditions what I said. What are the three conditions? Driving cell should be bigger, and our cell should be smaller, and they should have same order, like positive negative kind of thing, and galvanometer should be with the smaller cell. This question, when alpha particles go through a gold foil, this is the gold foil, actually these are gold nuclei. They say what we can learn that some of them are having a deflection and only very few of them are bouncing back. Most of them go straight through the gold foil. What we can learn, best way is to look at 2018 May 11 question 38. This question was repeated that time also. So from this experiment, what we cannot deduce is atoms are mostly empty. Of course it is, we can deduce, that's why most of them are going straight. Most of the mass of an atom is concentrated in the nucleus. Otherwise, these alpha particles will not be deflected, because those small people can't deflect. So this also can be deduced. The nucleus of an atom contains protons. Yes, but protons, we don't know protons. We can say nucleus is positive. That's the only conclusion. So this is incomplete. We don't know about protons. We can say the nucleus has to be positive. The nucleus of an atom is small. Small means size wise. That's also derivable from this experiment. 39. Now we have 4 nuclei. Let's think what's wrong with. They say which statement about about these nuclei is correct. Let's think about 1A. An uncharged atom of Q has 24 orbital electrons. Let's focus on Q. Q is this. No, this is proton number is only 13. So it has proton and electrons 13. So this idea is wrong. Nuclear number is 24. That's a different thing. Second one. Nuclei G and M are isotope of the same element. G and M. Let's see. This is isotope, same number of protons. No, that's also wrong. 3. And let's go to D quickly. When M emits beta minus particle, M transform into Q. M, beta minus and anti-electron neutrino. So this should be one more. So 13. But let's look at Q. Q is 24, 13. When M transform into Q, but the problem is, yes, this is good, but this mass number is not the same. So that's why this is also wrong. This is pretty close, but not good enough. When E absorbs a neutron and then emits an alpha particle, E transform into M. We have to write the equation. Let's think E absorbs the neutron. So E 2814 plus N10 changes into and then emits alpha particle plus alpha 42. So whatever is here, this should be 28 plus 29 minus 4, 25. 14 minus 2, 12. So this should be something 25 and 12. Yes, that is M. So it becomes M. That's right. So this answer is definitely correct. Question number 39, answer is C. Question number 14. A neutron is composed of a up quark and two down quarks. When neutron decays into a proton, beta particle is emitted, blah blah blah. Okay, they ask which quark structure changes in neutron when the beta particle emission is happening. Okay, beta emission we can write in 3 different ways. One is this way, thinking about whole nucleus. X breaks into A and Z. A, this is 0 minus 1, so this must be Z plus 1. So, or in other words, number of protons Z, number of protons Z plus 1. It means number of protons has gone in one higher. So it means a neutron changes into a proton and then beta particle and electron antineutrino. Or you can say this is up, down, down, this is up, up, down. So only change is a down quark changes into up quark. So you can write this equation: down change into up and beta minus and electron antineutrino. Answer is B. So these are my answers, and I'm pretty sure this is the marking scheme answers. So these are the marking scheme answers also. And thank you very much. This is my first effort of doing past papers for you guys. And if you like, I appreciate if you like this video, and I will keep adding more videos. So please subscribe. Thank you very much.